Assalamualaikum. Today we are going to discuss some physical properties of elements. First of all, in this video, we will discuss ionization energy. Here are some headings through which we can cover this topic. Number one, definition. How you can define ionization energy. Ionization energy can be defined as the minimum amount of energy which is required to remove electron from the outermost shell of its isolated gaseous atom in the ground state. Or simply we can say that if an atom has to remove electron from the outermost shell when this atom is present in gaseous state, some amount of energy is required. This amount of energy which is required to remove electron from the isolated gaseous state atom is called ionization energy. For example, in the case of magnesium, magnesium belongs to group 2A, alkaline earth metals. Magnesium loses its one electron and form cation. Energy is required to remove this first electron. It is termed as first ionization energy. Its value is plus 738 kilojoule per mole. While when magnesium cation is available, we can remove its second electron. Because magnesium is present in group 2A, it contains two electrons in its valence shell. It can lose its second electron also. But in order to lose its second electron from this cation, an additional amount of energy or double amount of energy is required. This is called second ionization energy. Next, moving toward its strength. Within groups and periods in the periodic table, in groups, ionization energy decreases from top to bottom within groups, while in period, ionization energy increases from left to right in the period. The reason is that in groups, as we know that atomic sizes increases from top to bottom, it is easy to lose electron from the elements which are present at the bottom of the periodic table. Same for the period. We know that when we move from left to right across the periodic table, atomic sizes decreases. Small sized atoms have difficulty in losing their electrons, so more amount of energy is required to remove electron from the elements which are present in right side. Two important reasoning questions are, while you can see that in the case of magnesium atom, first ionization energy value is smaller than the second one, or we can say that second ionization energy value is greater than the first one. In the second case, we need 1451 kilojoule per mole energy, while first electron was removed only by giving 738 kilojoule per mole energy. What is the reason behind this? We will explain it that first electron was removed from the neutral magnesium atom. Hold of nucleus on electron was less, due to which 738 kilojoule per mole energy was required. But once one electron or the first electron is being removed, it has become magnesium cation. We know that cations are always smaller than their parent atoms. We are removing second electron from this cation, not from neutral atom. Hold of nucleus on remaining electron increases. So that's why in order to remove second electron, extra amount or double amount of energy is required. Number two, second question is why these ionization energies are representing with positive sign. or why in the case of ionization energy, energy is required to remove electron. Why it is endothermic process? The answer is because there is hold of nucleus on electrons. To remove or to broken the hold of nucleus on electron, some amount of energy is required. That's why ionization energy is endothermic process. Here is a periodic table. In this periodic table, the values of first ionization energies of some elements are being shown. You can see that hydrogen has first ionization energy. Hydrogen can lose its electron when 1310 kilojoule per mole energy is given to it. While bottom of the periodic table, bottom of this group, cesium. Cesium require only 380 kilojoule per mole energy to remove its first electron or to remove its valence electron. It means as we move from top to bottom in the periodic table from hydrogen towards cesium, ionization energy is decreasing. It means in the group ionization energy values decreases. While we move from left to right across the periodic table in the period, hydrogen has ionization energy value 1310 kilojoule per mole, while helium has ionization energy 2370 kilojoule per mole energy is required to remove electron from helium. It means when we move from left to right across the periodic table in the periods, the value of ionization energy increases. It means extra amount of energy is required to remove electrons which are present on right side of the periodic table. It means right side of the periodic table elements are not good electron losers, yet they are electron gainers. While at the start of the periodic table, on the left side of the periodic table, because these are metals, metals have tendency to lose electrons, so that's why their ionization energy values are smaller. We can conclude that when we move from top to bottom within groups, the value of ionization energy decreases. While we move from left to right across the periodic table, the value of ionization energy increases. Two important factors are there on which ionization energy depends. Number one, atomic size, and number two, shielding effect. What is meant by atomic size? It can be described in the very simple way as the distance between nucleus to the outermost shell. When we move from top to bottom in the periodic table, atomic size increases. Hydrogen has small size while cesium has greater size. It means as the atomic size increases, hold of nucleus on electron decreases and less energy is required to remove electron. That's why atomic size has inverse relation with ionization energy. The second point is shielding effect. We can say that shielding effect is actually the repulsion between nucleus and outermost shell. Repulsion between nucleus and outermost shell, that is due to the electrons which are present between the nucleus and electrons. As the shielding effect increases, ionization energy value decreases. So it also has inverse relation. Thank you.